got some kind of crazy diarrhea, you know, you went down to Mexico, you drank the drinking water fountain, you drank water out of the fountain, boom, take some. So I should probably do 2 separate videos on diatomaceous earth and bentonite clay, but I'm going to combine them into one because I think you'll get the idea and understand how to think through this rather than me trying to tell you everything there is to know about these substances. Diatomaceous earth, let's start with that. It comes from diatoms, these little marine organisms. This is an electron microscopy picture, you know, a picture from an electron microscope. In other words, it's 10 microns, it's really small, and it's a cool organism. I mean, they're tiny, and they're obviously dead marine organisms, but look at it, they're real porous, so you can see how there might be some, you know, toxic substance, you know, ability for these things to pull toxic substances. So that's an interesting application. Let's talk about it. 2002, I've got here from the Archives of Toxicology Journal, a paper called Health Hazards Due to the Inhalation of Amorphous Silica. And what do they say? Occupational exposure to crystalline silica dust. Okay, so that's literally little shards of these diatomaceous earth organisms. You know, people that are working with this stuff, of course, they're exposed a lot more, but it's associated with an increased risk for pulmonary diseases, lung problems such as tuberculosis, chronic bronchitis, lung cancer, and other ones. So it's harming the lungs at high dose. And remember, they're talking about crystalline silica, that's little shards. So this review, it says, summarizes the current knowledge about the health effects of amorphous, non-crystalline forms. So that's what they're going for when you're trying to buy this diatomaceous earth. They're going for this non-crystalline. You don't want those little shards. The problem is, they say, the major problem is the assessment of health effects of amorphous silica is its contamination with crystalline silica. The problem is you can't get it without the little shards. So is that an actual issue in animals? Let's take a look. There's really not that many human studies, so let's look at the animal studies. Here we've got one, 1998, in the journal called Animal Science. It's called Effect of Diatomaceous Earth as an anthelmimetic treatment. It's a word you don't hear every day, anthelmimetic. That means anti-parasitic, like parasite killing treatment on internal parasites and feedlot performance of cows, beef steers. So they literally did a random control trial with cows, and it says steers were adapted to a cereal-based diet for 15 days on the farm of origin and given an additional 21 days to adjust to the feedlot diet. We all know that's not a healthy way for cows to live, but it's the way we do things. So it's the way they're running things here on this. So what they did, they set up 3 separate groups. They had a control group where they actually gave an anti-parasite drug, like they always do. They had another group where they didn't give them anything. And then they had a group where they gave them 1/3 of a kilogram of diatomaceous earth. That's a lot of diatomaceous earth. So anyways, they obviously said that all steers were positive for nematodes at the beginning and some other parasites. So here's the results. The controls, that means the ones that didn't give anything, in the diatomaceous earth diatomaceous earth group had higher parasite levels than the drug group. So they were comparable. In other words, this earth didn't do anything. This did this for 46 days. But here's the good news, was that the diatomaceous earth didn't have any effect on body weight, average daily grain, dry matter intake, or food conversion. Man, I'm having trouble saying this word today. But anyways, it didn't have any harmful effects. So yeah, it didn't really kill the parasites, which is interesting, but at least it didn't harm the cows. So one other quick thing to note on this topic from 2010 from the Journal of Economic Entomology. I've got a study here called Acaricidal, that means mite killing, another funky word. Acaricidal effect of different diatomaceous earth formations against Tyrophagus putrescens on stored wheat, some kind of mite. Okay, so does diatomaceous earth kill mites? Let's look. They used 5 different earth formulations, and essentially they said even the low dose killed 78% of the mites. So what essentially happens is it dries out their exoskeleton and it kills them. But that doesn't happen in your gut. That doesn't happen when you eat this kind of earth, because there's liquid everywhere. So I don't think it's as powerful or powerful at all, but and it may even cause irritable bowel syndrome. It may puncture your intestinal walls. I mean, that seems likely to me. So it seems like a high risk for a low benefit situation. Let's move on and talk about clay. Clay, I think, is really positive, but there's also some risks here. We'll talk about it. 2015, Journal of Animal Science and Biotechnology. I've got a paper here called Clays as Dietary Supplements for Swine, for Pigs, a review. This goes over all the literature. We don't have to go through a ton of papers. We'll just look at this one. Dietary supplementation with clays has been shown to improve weight gain and feed conversion in pigs. Makes them bigger. Why? Because they're absorbing more nutrients. They go on to say it. Clays reduce the speed of passage of feed along the digestive tract. It slows down. It's bulky, which allows more time for digestion. Feeding clays also causes morphological changes in the intestine. That's interesting. In other words, there's actual structural changes in the intestinal walls. Increase in villi height. What are villus or villi? They're these little ridges along your intestinal walls. The entire thing is lined with them. They almost look like little hairs sticking out. And in other words, the clay actually increases the height of those, which means your intestinal walls are stronger, and they increase they absorb more nutrients. They pull more nutrients out of the food. That's awesome. Lots of benefits here with clay, at least. And what else? They explain that this increases the surface area of the GI tract, thus increasing nutrient digestibility. Feeding clay also reduces the severity, incidence, and duration of diarrhea. If you've got some kind of crazy diarrhea, you went down to Mexico, you drank the drinking water fountain, you drank water out of the fountain, boom, take some clay. It helps. This is scientific research. This is a review. They also said it helps mitigate the effect of mycotoxins. That includes mold estrogens and other mold toxins. And heavy metals are included here. So a lot of things. So in other words, clay has a lot more diversity. It's probably, it's volcanic ash. So it probably has a lot more porous structure, and it works. Scientifically, it works. Here's another one specific to viruses, also relatively new research in the Journal of Science of the Total Environmental, of the Total Environment Journal. It's called Interaction of Human Adenoviruses and Colophages with Kaolinite and Bentonite. They're looking at clay. What do they find? It removes fecal indicators of viruses. It pulls out viruses too. That's not included in that other review. Here's the one caveat I want you to know before we go. 2007, the Journal of Hazardous Materials has a paper on the absorption of copper and zinc from aqueous solutions by using natural clay. What did they conclude here? Natural clay can be used as an effective adsorbent for removing copper and zinc from aqueous solutions. In other words, it's non-specific. It's going to pull out the mercuries, those heavy metals. It's also going to pull out copper, zinc, other important trace minerals. So you don't want to be taking it all the time, constantly after meals. But it's got its uses. And keep in mind that if you've got toxins in your blood, clay is not going to magically take those out of your blood. You need to get some chelators or something and bind those and urinate those out through, those bind like EDTA and these other chelators, depending on what type, whether you have lead or maybe if you have mercury, use a different one. But those kind of toxic substances in your blood already in your body, you've got to get those through your kidney, get those out through your urine. These clays, it doesn't matter, diatomaceous earth, that's not going to magically pull that stuff out. Neither is charcoal. We'll talk about charcoal next time.